Good morning everybody and welcome to our course on Introduction to Mechanical Micro Machining. In the last class we have seen some of the criteria for selection of the material for fabrication of machine tool structure, and we have also seen that what are the properties are required so that you can get the required result or the required strength of the structure, so that it should not deform or it should not create a problem during machining under the vibration and the forces acting onto the different type of components. So, let us further go into detail that what are the different properties it should possess, so that you can get the required results. So, one of these parameter is the density versus Young's modulus. Now, if you see this particular graph, now on the x axis it has a density written and on the y axis it is the modulus. Now, there are different materials. What we need, that we need a high Young's modulus for our, so it should not deform under any type of external forces or it is under a different type of stresses, and our density of, that means our weight should be low if possible, because we want a light structure also. So, to get this both the things, it is very difficult to get a one particular material which will fulfill all the requirements. So, if you see this particular thing, foam is creating a very large amount of occupies large amount of area, because foam has a very small Young's modulus, because you can, it is something like a rubber or elastomer type kind of things. So, foam is very, because mostly it is used for packing material. When you ship any component which is very important or very delicate, at that time you wrap with this component with foam and it will sustain a type of impact loading or the different type of loading. Then what is our important thing is that we are actually looking something about this area, and even some ceramics are also included in their space, because what we want, that our workpiece or the construction material should not actually deform. So, we need a high modulus, but we have to also think about the weight of the component, that per volume how much is the weight. So, if you see this particular thing, that this particular part is there something which is very important for our case, where it has a reasonable amount of Young's modulus and the density is also comparatively good. So, we have to look into this particular area. So, major class of material with respect to density, specific weight and the Young's modulus is shown here in this case. So, for lightweight design, because what we need, that we need lightweight design also, because many times what happen, that if when you are doing a machining at a on a very small scale, you need a frequent travel in to and fro direction. So, if your workpiece material is very large, or the all the guide way and slide way is very heavy, then movement is very difficult, quick movement is difficult. So, what is required, the when you are talking about the lightweight design, what we need, that we need a density specific mechanical value. So, that is that Young's modulus divided by density. Young's modulus divided by density is that is called the density specific value. To it becomes more important, because we do not want a machine is very heavy, and sometimes if you go with this particular direction, you have to go with the higher density also, but that is we want to, that is we do not want to do in this step. So, this is one of the criteria or by which you can actually select a different types of material which will fulfill both the things, that it has a high Young's modulus as well as the reasonable amount of density, so that you can get the required things done. Another thing is strength and the specific energy consumption. So, this is one more graphs. So, here different materials are given, and the y axis it is a strength. So, this strength is increasing, this is the specific energy consumption. So, what is the specific energy consumption? Because if you see these materials, that these materials are not readily available, that means wherever you are getting, you have to process these components. So, from starting to end, let me define first this, the specific energy consumption. What is that thing? The energy required to make the material, right. So, what you are doing, you are starting with the raw material. First is the raw material, from where whatever way you are getting, either you are getting a chemical route or it is readily available in the nature. Then what you do, you have to refine this thing, because whatever is the raw material, you have to remove or you have to separate all the different elements. then you have to make sure that the component or the content of this material is same as whatever material you are thinking. So, refining is the second step. Once refining over, then you have to shape this component. There are shaping, you can do many things, there are machinings are also available. If it is in a powder form or something, then powder metallurgy. If you are getting in terms of very small different type of shape, then there are different process available, that is called right. Then you are doing actually forming, metal forming. Then there are casting. So, by that you are actually shaping the material. So, these all processes are for the shaping of material. Shaping of material, correct. So, now raw material, how much energy you are actually spending for making a one particular material. So, starting from raw material, refining, shaping of the material related to the 1 kg of material and its density, correct. So, if you are, how much energy you are spending for creating a 1 kg of material of a required shape, that is raw material, then refine, then shaping and all this. So, that is called specific energy consumption, right. So, now how it is important. So, now if you see here, so these are the polymer from woods and all these things are over here. You do not need to spend more energy to shape these things, right, because these are soft material, and but problem is that this strength is also very low. So, this particular category of material, whatever it is showing here, these are not suitable for the construction of the material, not suitable, correct. Now, what you have to think about that, you need high strength. If you go in this direction, now see, let us divide this part in terms of strength, correct. So, these are the strength axes. So, now if you look about this particular thing, suppose you are going with a 1000 MPa or 1 GPa. So, at that time you have reasonably good amount of material, but problem is that for processing those components you have to spend huge amount of energy. So, that is the big problem. So, initially your cost will be very high, because refining, shaping, these things are not as easy as processing the woods and the different type of elastomer in this particular range, because glass are very difficult to cut material, because you have to use special tooling for that. Then if you go in this particular thing, the strength is very high, then cutting forces are very high. Even for melting of this particular material, you have to go with high temperature, then only you can do casting and other processing. So, this is the graph which will tell you that at which particular location you have to stop, so that you can get the required results. But if you see general way, this particular trend is going in this direction. So, this is the routine, that if you go with a high strength, your energy, specific energy requirement or specific energy consumption is also high in this particular direction. So, now first you think that how much time, because whatever energy consumption you are putting here, that will directly converted into the cost and time, right. Both things are important, because you cannot avoid or you cannot ignore this particular thing when you are making a machine, because that is directly connected with the cost. If you want a very steep structure and you do not want to sacrifice any of this strength material, then what you have to do, that you have to go with the high specific energy consumption material, then cost will directly go up, and then you have to actually put a break even in such a way that whatever component you are processing by this construction material, where you have already spent lot of money, then you have to find out that if the component cost or whatever job work you are getting through this machine, it should actually justify the amount of energy or amount of money and time you have spent for making this construction. So, after 1 year or 2 year or after 10 years, you should be in the profit, not into the continuously in the loss market, right. So, this is the trend, that means if higher the strength or more the energy consumption is required, that is what is showing in this particular diagram. Just you draw this thing, most of the things it is balanced in both the directions. So, this is the trend, right. So, now wall construction for a slide. Now, what we need, that this is something very important, that this consider this 19 example first, correct. So, now what is this rib, that suppose you have a guideway, this is guideway, and on the top you are actually moving one component, suppose this is the component and then you are actually moving by force. So, it has a weight, correct, and now consider that what should be the structure of this particular guideway, and this one is the component, right. So, what should be the structure of guideway, correct. So, first start with the solid one, because now what is the criteria, that we have to actually see the strength versus weight, correct. So, this is the criteria we have to follow. If you are making a solid structure, actually your weight will be very high, in this case W is very high, and then there are lot of different type of options, which type of ribs you require, because these are called the ribs, whatever is this showing. So, this is the rib, correct. So, what is design which is important, now how you define. So, this is our one norm displacement, because if you put a theoretical bending load at the end or at some other location, at that time what should be the displacement. So, our objective is to reduce this displacement, okay. Displacement should be reduced, displacement should be less under loading, correct. So, now if you see this one, the 19 has the probably the lowest one, correct. It is the completely solid body, but again our weight is very high. So, now we have to find out what are the other shapes or the other configuration by this particular rib structure, which is giving a less displacement, but let it be higher than that, but it should be within the permissible limit, because here what we are doing, that whatever structure you are using this thing, you are using less material here, but you are not sacrificing the strength in a large way. So, now if you see this particular line, so there are many things are there. So, 10, 11 is there, then 16, 17s are there, 14 are. So, these are the particular structure which are important for using this type of 16, this is there, and 17 is also there. So, you can select any of this particular structure depending on the availability of the machine tool or the processes which can fabricate this type of structure, because if you go with this thing, mostly you create this 2 bar and then you weld it, that is one of the options. Then another way you can do casting also, by which you can make this type of structures. So, by this way actually you have to find out which one is the optimum design for a strength to weight ratio, so that you can get the required result without any sacrifice. Right. So, there is another category which is called honeycomb slide structure. What is this thing? The machine slides are excited by driving or the process force as well. So, there are two type of forces. One is the driving force, that means when you are moving axis in this direction, that means you are traveling your tool. So, this tool is traveling and then your workpiece is located here. So, when you are traveling, at that time what happened, that you have to spend some energy to move this thing, either tool or the workpiece in this direction. So, at that time it will create some forces, and the process is force, that means when you do actual cutting, at that time you will encounter forces, that is called process force. So, what is our requirement? Our requirement is the lightweight, but the high stiffness and damping. That means, your particular slide structure should not deform, and it should not transfer vibration to other components, or you can say it absorb vibration. It should absorb vibration. Another thing, it should be lightweight also, correct. So, you have to, these two requirements are actually opposite to this one. So, you have to be in a one type of balanced way, so that you can get both the things in a reasonably good way. One is the lightweight and another is the high stiffness and the damping, right. So, what is the importance? So, this is one of the structure which will fulfill this particular requirement. So, what is this structure? So, this is the structure. Now, what we are doing here, that this is the honeycomb. So, if you see the honeybee, that honeybee house, at that time you will get this type of structures. Correct. So, these are the structure by which you can get the So, this way there are many different structures available. So, in this way you can get the very high dense structure by this particular honeycomb structure, and when it is a wall. So, this will actually get a very high stiffness and the damping, and you know that it is a mostly hollow part. So, these are the hollow things, you do not have material, it is not a solid body. So, its weight will be also less. So, once you get this structure, then what you have to do, that you bolt it or weld it from both the sides, from the bottom and from the top, and then you are getting a one particular structure which can be used for making the slide structure of the machine tool, correct. So, this is the one of the ways of doing. Another structure was showing in the earlier slide, but this is also very used. And now you might have seen this type of structure in the paking, because when you pack any very sophisticated or very sensitive instrument, at that time from outer side you are putting this type of box. So, it is mostly a foam, honeycomb structure, foam with honeycomb structure. So, that is used for packing material, but right now here what we are talking about the construction material. So, foam is not a right solution, because right material we have seen in the two slides before, where the material with respect to the Young's modulus was showing that what was the density and this particular thing. Since the density is low, but its Young's modulus is also very low. So, it is not the correct way. So, you have to go with the honeycomb structure, but with the metal or some type of other material which is very high Young's modulus. Right. So, other than that, whatever we have seen, that we can use different type of metal, but there are light metals are also available. Mostly it is a aluminum alloy or the magnesium alloys. So, these materials have significant lower density compared to the steel and cast iron, because we know for construction material mostly we prefer, for the base material we prefer the cast iron, for other materials we prefer the steel, but the density is high. So, your weight will also increase, and once the density is very high, machining is also not that much easy. You have, because and ultimately you have to process it, or you have to shape this material. So, that will also take lot of time and energy. So, aluminum alloy is one of the choices by which you can replace some of the components of steel and cast iron, not all. Masses of the moving machine component can be reduced, because now this is very important, because you know that suppose you have one component here, this is the component and this is the slide on which it is mounted. So, and you want to do some small scale micro machining here only. So, this is the area of micro machining, right. So, here you might have a lead screw, and this particular table is attached with this thing, and you have a motor which is rotating this lead screw. So, whole thing will move. So, let us give something like this. So, this is a very heavy object. Correct. So, now if you see this particular thing, this you consider as a slide way or guide way, correct, GUIDE, guide way. So, if you are using with a steel and cast iron, your weight will be very, because you already have a heavy object, and other than heavy object your guide way is also very heavy W. So, in this case when you are moving this by lead screw, this motor will provide a very because it will be loaded more, because it has to provide such a high torque that so that it can move this object in different direction, maybe in to and fro direction or in the left or right direction depending on your axis. So, when you are doing this thing, you cannot get a very fast movement, that means your feed rate will be very low. Correct. So, if you are using some type of light metal at that time, you can actually increase this feed rate to a acceptable limit, so that you can get material removal or you can get the production rate very high. So, frequent movement here and there, it is a problem. So, one of these advantages is that you can use for making your machine component light, so that it can move very easily without any problem. So, reducing the mass and inertia of the fast rotating tool allows the shorter run up time and energy saving. So, what does it mean? That suppose you have a solid body, okay, and you want to rotate it. Okay. So, when you rotate it, at the time what happens, that you have, now suppose you want to rotate it to the 1000 rpm. Okay. So, right now it is in stationary position. So, to reach to the 1000 rpm, what you have to do, that this is the rpm and this is the time, right, and this is the 1000. You want to reach to this location. So, when you start with a heavy body, now what happens, that you have to spend some time, because it suddenly will not reach to that location 1000. So, this is the time duration required to reach to the 1000 rpm, right. So, this is the time, correct. Now, because it has its own weight, so inertia is very important role, because when you are rotating at a high rpm, you have to pay more time, or you have to spend more time here to reach to that location, and same thing for stopping it also. If you continue this particular line and then you have to stop this thing to 0 location, again you have to spend very large amount of time in this direction. But this is very important here. Now, consider this particular object. Now, you have a hollow object. That is one of the solutions, by this way, that you can reduce, you can change this particular thing, but now you consider that this body, now you are changing this body, now it is a lightweight. Lightweight structure. Now, what is going to happen in this case, that it may not require so much of time, and then it will reach to this location, and when it is ending here, it may not require same amount of time here. So, whatever is this time now, the time required for shorter run up. So, this is called shorter run up. Right. It will quickly reach to that location, because now you know that you want to do machining on this operation. Suppose this is the one workpiece and it is connected with the spindle and you want to rotate it to the 1000 rpm and your tool is located already here, correct. So, this is your cutting tool. Unless it reaches to the 1000 rpm, you cannot process this particular thing, right. Your step is you are waiting for 1000 rpm. So, now consider it is let it be a fraction of second, but if you are making 1000 of this component, this fraction of second will be multiplied by thousands of time, correct. And you maybe sometimes what happened that you want to change some tool, at that time you are stopping the workpiece, but you are not changing the workpiece. So, single workpiece is processing 2-3 times with a stopping and starting of the spindle. So, at that time you are spending large amount of time in just waiting to reach to that particular setting parameter. So, shorter run up will help you in this case, so that you can quickly reach to the required time, required parameter setting, and you can start the machining operation. So, ultimately it is a energy saving without any problem. Right. And wall thickness can be increased in order to reduce the local strain, maintaining the component weight. Now, how it will helpful us in this case? Now, consider this is the component, let me draw it again. This is the rib and you consider your force is at this location. Okay. So, this is right now steel, or let us make it from cast iron. Correct. So, now this is the thing. So, now when you are putting, so this thickness is playing important role here, because whenever you are load putting, so stresses will be very high at this location. Correct. So, now this is the cast iron. Now, if you use this aluminum alloy, now we know that aluminum alloy is light compared to cast iron, it is heavy, correct. So, now what you can do, actually you can increase the thickness of the rib. Now, you provide the same force. Now, this T and this T, T1 and T1, this is T2 and T2. So, T2 is higher than T1, correct. So, in this case what you can do, that you can actually increase the wall thickness here, whatever, to reduce the local strain in this case. So, now your thickness is little bit more compared to the earlier case. So, your stresses will be expectedly low, maintaining the weight of the component, because now we know the density difference is high. So, even if you increase this thickness, your weight will not be increase such a high rate, because there is a density difference. So, weight will be same for both the cases, even though it is a this thing. So, that is W1 equal to W2, even though you are increasing the thickness of this part. So, that is the one of the advantage of using lightweight metal, but you can use this thing for some of the components only, not all the components, because these materials are not very useful for some of the components, which can be very harmful for this. So, at that time you need to use for steel or the cast iron only to get the things done. So, let me finish this lecture here and let us continue this talk further in the next class. Thank you very much.